All right, everybody, we're back for some more. And we're going to go and do some test 2 problem. Looks like it's part of the scheme here for questions 1 through 18. Yours will not be a huge scheme like that, but this has some good practice. We can't really do product 4 as the student requested without looking at products 1, 2, and 3. So let's quickly get to those. We have 3-methyl-1-pentanol. 1-pentanol being this species here. 1, 2, 3 with a methyl. And PCC will make that into product 1. 3-methyl-1-pentanal. And then product 1 is going to be treated with NaOH. And generally, when you see a reaction where the first part's NaOH and then the next part's NaOH and heat, I would always be thinking about the combination of the aldol reaction followed by the aldol condensation, and that will serve you well here. This is a simple aldol. And you copy your molecule, missing an alpha H. Stick figures, they're always missing. So just remember, from the alpha position, you're going to draw a new bond. This molecule attacks a second molecule when it becomes an anion right here. Anion attacks carbonyl of molecule number 2. And you get an alcohol. That's the all part of the name aldol. 2, 3, 4, 5. So there's product 2. Aldol, aldehyde alcohol. And the heat with the hydroxide allows that to condense to the smaller product with the alpha beta unsaturated pi. And remember, if a group has to stick off of this carbon, it would prefer going towards the less hindered sp2 oxygen. So I wouldn't put it towards the more hindered sec-butyl group here. So I would do my double bond and then the alkene carbon coming off here. And that's 3. And we can finally get to our student's question. There's molecule 3. It's an alpha beta unsaturated aldehyde or ketone. In this case, aldehyde. Those are perfect electrophiles for what's called a 1,4 addition. Why am I thinking about a 1,4 addition? Well, I looked at the reagents that the student had circled, and I saw ethyl acetoacetate. We must know that that molecule has an ethyl attached to an ester, attached to an acetic acid. There's ethyl acetate. Ethyl acetate. We need the aceto off of the alpha position. Here's an aceto. There you go. And that molecule, as we just saw on our list of new pKa's, has a very accessible pKa 10 between 2 carbonyls. That means when we see any kind of base in here, that's the first proton that's coming off. You're not going to take off this 20 over here before you take this 10. We'll bring that up later again during this lecture. We always take the lowest pKa first. So this is going to become an anion when KOET is with it, and clearly it is. That anion is a 1,4 nucleophile for the very reason that this is a moderately strong acid. This anion is not only a good nucleophile for attacking here, but it's also a good leaving group when it attacks here. And this comes up and comes back and kicks it back off because we eventually want to make this bond here to the 4 position. The 4 is interesting name, and you have to look at the lectures for that. It has to do with the mechanism, the 1,4 edition. So product 4, it's going to have everything this molecule down here has. I'll monochromize it to one color here. 1, 2, 3, 4, 5 methyl here. And we have a new bond this time to here. The nucleophile C- is going to attack here. Electrons resonate up to an enolate, and the enolate then becomes the conjugate base when ethanol provides a proton and puts a new alpha H over here. Let's see. First, let's draw our new bond, okay? We did it. And it is to a carbonyl carbon. That's an ester. And on the other side, it's this. And this new H that I haven't drawn here, don't really have to draw it, but here it is. Purple H, that's right here. Right here. Came from ethanol. And that is the product we're looking for in product 4. Naming wise, interesting story here. If you want to go with the longest chain, this will get us a carbonyl on 2. And I think it's a tie going 5, 6, 7, 8 or 5, 6, 7, 8. Let's go towards where we have another group. And another question the same student asked is, how do I name that as a group? And that being this functionality here is, and yeah, it's a 4-meal group. 4-meal is a nice group. And yeah, it's whenever you have just an aldehyde piece sticking off of anything. And it's a relative to acetyl, which is even more common. So if you have that sticking off something, it's called acetyl. Acetyl, one of the most common prefixes in biochemistry. Acetyl. That's just an aside. Okay, so nomenclature-wise, well, why don't we use this new acetyl thing here? Well, we wouldn't get the longest chain if we started here. There's multiple ways of naming that. We're going to have to name this as a carboxylate off of 3. But I'm rethinking this whole process here, and I'm saying, wait, no, fall 20 was the first time we did this, and we just had students write their products down. So the naming part takes more time. It's important, but I had to find ways of cutting down on the amount of time. So naming this is not important now. You would just have to draw it for me, and I would grade it based on what you drew for me. So I'm not going to go ahead and name it. But it is a good thing to know in nomenclature, that little piece sticking off can be called 4-meal, and a slightly bigger piece with a methyl there would be called acetyl. Take that home, even though I'm not testing you on nomenclature at this time. We'll leave this as a mini segment and we'll come right back.